Our objective in this lesson is to describe the relationship between the coefficients and the roots of a quadratic equation. As a sort of a review, let's have an activity. Looking for perfect match. Given the value of the discriminant, match it with the nature of the roots of the quadratic equation. If the value of the discriminant is negative, we do not have real roots, just pair of complex numbers. If the value of discriminant is 0, then the root is only 1 but repeated twice. If the value of the discriminant is positive and it is a perfect square, the roots are rational numbers and not equal. And if the value of the discriminant is positive but not perfect square, the roots are irrational numbers and also not equal. Let's have another activity. You complete me. Supply what is asked. Given the quadratic equation, we are going to give the a, b, c, the roots, the sum, and the product of the roots. Let's have the first equation. A here is the invisible 1. B is negative 4. C is negative 5. For the roots, the easiest way to solve this is through factoring. And the factors are x plus 1 times x minus 5. X plus 1 equals 0, so x equals negative 1. X minus 5 equals 0, x equals positive 5. For the sum, we only have to add these two. Negative 1 plus 5 will give us positive 4. For the product of the roots, we simply have to multiply these two. Negative 1 times 5 is negative 5. The second one, a is the numerical coefficient of the variable raised to the second power, so that would be 3. B is positive 4. And C is negative 7. For the roots, I already solved this quadratic equation in our topic, solving quadratic equation by quadratic formula. And the roots are x equals 1 and x equals negative 7 over 3. For the sum of the roots, again, we simply have to add these two. Let me replace 1 by 3 over 3, and then plus minus will become minus. Same denominator, we simply have to work on the numerator. 3 minus 7 is negative 4, and then copy the denominator. For the product, let us multiply these two, and it will give us negative 7 over 3. Let us continue our activity. This time, let's name it, We Are Connected. Discover the connection between the sum and product of roots and the values of a, b, and c. Notice this column, the sum of roots. Let us see if there's any way we can build connection to the values of a, b, and c. Let me start with the second quadratic equation. The sum of roots is negative 4 over 3. I have here 4 and I have here 3. If I am going to take the negative of b, that will become negative 4. And then divided by a, which is 3, I will have negative 4 over 3. Let's see if it will work in equation 1. Let me get the negative of negative 4. That would be positive 4. And then divided by a, which is 1, is still positive 4. Therefore, the formula for sum of the roots is actually equal to the negative of b over a. Now, for the product of the roots, I have here negative 5. I also have here negative 5. I have here negative 7 over 3. I have here negative 7 and 3. If I am going to divide my C by my A, in this case, it will become negative 7 over 3, which is actually the product. Let's see if it applies to quadratic equation number 1. Negative 5, my C, divided by A, which is 1, is still negative 5, which is the product. Therefore, the formula for product of roots is indeed C over A. Let's have another activity. Get the sum and product of my roots. Given the quadratic equation, first we have to determine the values of A, B, and C. A here is 3, B is negative 5, and C is negative 7. For the sum of the roots, we have discovered in our previous activity that it is equal to negative b over a. So the sum of the roots will be the negative of negative 5 divided by our a, which is 3. Negative of negative 5 is positive 5 all over 3. This is the sum of the roots. Now, for the product of the roots, we have discovered earlier that the formula is C over A. So the product of the roots will be C, which is negative 7, divided by the A, which is 3. Let us have another one. A is the invisible 1, B is 3, and C is negative 4. For the sum of the roots, again, that is negative B over A. So it will be the negative of B, which is 3, so negative 3, divided by the A, which is 1. And negative 3 over 1 is still negative 3. For the product of the roots, we have C over A, and our C is negative 4 divided by the A, which is 1. Negative 4 divided by 1 is negative 4. Let's move on to our next activity. My equation lies within my roots. I will teach you the first method on how to determine the equation given the roots. First, I'm going to transpose negative 2 on this side and equate this to 0. I'm going to do the same thing here, moving this on this side and equating to 0. These now are my factors, quantity x plus 2 times x minus 3. From here, I'm going to use FOIL method. X times x is x squared. X times negative 3 is negative 3x. 2 times x is positive 2x. 2 times negative 3 is negative 6. Negative 3x plus 2x is negative x. So the final answer would be x squared minus x minus 6 equals 0. Let's have another one. This time we have x equals 1 and x equals negative 7 over 3. I'll move 1 on this side and equate this to 0. I'll move negative 7 over 3 on this side and then equate this to 0. These are now my factors. This time, allow me to use the SMILE method. X times x is x squared. Negative 1 times 7 over 3 is negative 7 over 3. Negative 1 times x is negative x. X times 7 over 3 is 7 over 3x. To eradicate this 3 here, I'm going to multiply everything by 3. 3 times x squared is 3x squared. 3 times negative 7 over 3, the 3 here will simply cancel out. So I have negative 7. 3 times negative x is negative 3x. And 3 times 7 over 3 of x, 3 will simply cancel out. So I have plus 7x. Negative 3x plus 7x is positive 4x. So I have 3x squared plus 4x minus 7 equals 0. So again, this is the first method. From the roots, we were able to get the equation by converting the roots into factors. This time, method 2. I'm going to use the sum and the product of the roots that we have learned earlier. First, let me get the sum of the roots, negative 2 plus 3, and that is equal to positive 1. Since the formula for sum of the roots is negative b over a, and 1 here can be expressed as 1 over 1, then I'll simply have to get the negative of this to solve for my b. The negative of 1 is negative 1. And then the denominator 1 will be my a. So I have now the value of a and the value of b. Now for the product of the roots, let me multiply this 2, and that is equal to negative 6. The product of the roots is equal to c over a. And negative 6 can also be expressed as negative 6 over 1. So negative 6 is my c, and 1 again is my a. So I have now the values of a, b, and c. A is equal to 1, b is negative 1, and c is negative 6. I'll just add x squared for a, x for b, and nothing for c. So the quadratic equation will be 1x squared, or simply x squared, minus 1x, or minus x, and then minus 6 equals 0. The same answer that we got earlier. Let us solve also the second example that we solved earlier. So the sum of the roots, I'll simply have to add 1 and negative 7 over 3. Let me replace 1 by 3 over 3 and then plus minus will become minus 7 over 3. Same denominator, let's work on the numerator. 3 minus 7 is negative 4. Copy the denominator. Again, the formula for sum of the roots is negative b over a. So to solve for b, I simply have to get the negative of negative 4. And then my a is the denominator here. So the negative of negative 4, and that is equal to positive 4. So my a is equal to 3. My b is equal to 4. For the product of the roots, let me multiply this too. And this will give me a product of negative 7 over 3. Again, the formula for product of the roots is c over a. So the numerator here is my c, and the denominator is my a. So a again is equal to 3, b is equal to 4, and c is equal to negative 7. Just add x squared for a, x for b, and nothing for c. So the quadratic equation would be 3x squared plus 4x minus 7 equals 0. Again, the same answer that we got earlier. Now, try this. Determine the sum, the product, and the roots of x squared plus 3x minus 28 is equal to 0. First, let us determine the values of a, b, and c. A is 1, B is 3, and C is negative 28. The formula again for the sum of roots is negative B over A. So that will be equal to the negative of 3 divided by A, which is 1. So the sum of the roots is negative 3. For the product of the roots, that is C over A, C is equal to negative 28, and A again is 1. This will give us negative 28. Now, for the roots, the easiest way to solve this is by factoring. So allow me to get the factors of 28. Those are 1 and 28, 2 and 14, 4 and 7. Let's bring out our magic x. Let us write the numerical coefficient at the top, negative 28, and the numerical coefficient of the linear term, 3, at the bottom. Now let us decide which among these factors would possibly give me an answer of 3. That is possible when you choose 4 and 7. To give you 3 as an answer, 4 must be negative. So let us check. Negative 4 times 7 is negative 28. And negative 4 plus 7 is positive 3. So these are our factors. X minus 4 equals 0, or x plus 7 equals 0. Moving this on this side, x is equal to 4. Moving this on this side, x is equal to negative 7. The sum, the product, and the roots. Let us do extra challenge. Derive the relationship of the sum and product of the roots to the perimeter and area of a rectangular lot whose area is 144 meters squared with a perimeter of 52 meters. Let us draw a rectangular lot. Consider this as our length and this one as our width. The area of the lot is 144 meters squared. We know very well that area is equal to length times width. Let this be our equation 1. And we also know that perimeter is equal to twice of the length plus twice of the width. Let this be our equation 2. We are given that perimeter is equal to 52. Let us substitute that in our equation 2. We can all divide these terms by 2. Let us do that. 2 and 2 here will cancel out as well as the 2 here. And 52 divided by 2 is 26. So we have 26 is equal to L plus W. From here, we can solve for the value of L in terms of W. Let us move W on this side. So L is equal to 26 minus W. Let this be our equation 3. Now let us combine equation 1 and equation 3. area is equal to length times width. We are given the area here, 144. And we have now the value of L, which is 26 minus W. Let us substitute this two in our equation. Let us continue. From here, we are going to distribute this W. W times 26 is 26W. W times negative W is negative W squared. We're going to make the leading term positive, so we're going to move these terms here. It will become positive W squared minus 26W plus 144 is equal to 0. From here, we can determine the values of A, B, C. A is equal to 1. B is negative 26, and C is 144. Let us recall the formula of sum of the roots, and that is negative B over A. So that would be the negative of negative 26 over A, which is equal to 1. Negative of negative 26 is 26, and 26 divided by 1 is 26. For the product of the roots, that is C over A, our C is 144 and our A is 1. 144 divided by 1 is 144. Now let us see. Is there a relationship between the sum and product of the roots to the perimeter and area of the rectangular lot? 26 is half of 52. So we could say that the sum of the roots is equal to half of the perimeter of the rectangular lot. 144 here, which is the product of the roots, happens to be the area of the lot. So we could say that the product of the roots is equal to the area of the rectangular lot. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. One of the roots of x squared minus 11x plus 28 equals 0 is 4. What is the other root? Let us determine the value of a, that would be 1. B is negative 11. And C is 28. One of the roots is 4. Let us say this is the first root. X of 1 is equal to 4. The product of the roots is equal to C over A. Product of the roots, the first root multiply with the second root. We have the values of x of 1, C, and A. Let us substitute those. 28 divided by 1 is 28. To solve for the value of x of 2, we have to divide both sides by 4. This 4 here will cancel out, and 28 divided by 4 is equal to 7. So this is the second root. X of 2 is equal to 7. Second problem, the sum of the roots of a quadratic equation is 2. If one of the roots is 8, determine the quadratic equation. The sum of the roots is 2, so x sub 1 plus x sub 2 is equal to 2. And one of the roots is 8. So let us say x sub 1 is equal to 8. Let us substitute x sub 1 in this equation. So 8 plus x sub 2 is equal to 2. To solve for x sub 2, let us move 8 on the other side. It will become 2 minus 8. And this is equal to negative 6. Now I have both of the roots. X sub 1 is 8 and x sub 2 is negative 6. Since sum of the roots is equal to negative b over a, and 2 here can be expressed as 2 over 1, to solve for b, like what we did earlier, we simply have to get the negative of this. So b over a is equal to the negative of 2 over 1. Now, for the product of the roots, that would be x of 1 times x of 2. I already have it here. 8 times negative 6. And that will give me negative 48. And this is equal to C over A. The product of the roots is equal to C over A. And negative 48 can be expressed as negative 48 over 1. So my C is negative 48 and my A is 1. I now have the value of A, the B, and the C. We're just going to add x squared for A and x for B and nothing in C. So the quadratic equation will be x squared minus 2x minus 48 is equal to 0. Gets? Our next lesson is solving equations transformable to quadratic equations.